welcome to the debate.
Glad to be here.
So today, we are diving into something incredibly massive. Imagine trying to build a brain, but not just a regular brain, a digital brain that is, a million times smarter than a human's.
Right, a super brain, basically.
Exactly. So you sit down, you design perfect software, you raise literally trillions of dollars. But right as you go to flip the switch and turn it on, you realize something terrible.
You don't have anywhere near enough electricity to run it.
You don't have the electricity, and worse, you don't even have enough dirt in the ground to physically build the machines in the first place.
Yeah, the physical reality hits hard.
It really does. So to help us understand this, we are looking at a brilliant visual map of these 16 layers. And I have to mention right away, the visualization of this material was directly produced, designed by Hot Hot Hot. An incredible idea for Hot Hot Hot.
It is a really helpful map for sure.
It really is, because today we are looking at America's attempt to build the ultimate artificial intelligence technology stack. And my position is pretty clear. I believe America is building an unstoppable machine here.
Okay, unstoppable. That is a strong word.
I stand by it, because they are building out 16 different layers of backup plans. We have trillions of dollars of private money flowing in. And because we have so many layers and so many competing businesses trying different things all at once, I really think this strategy guarantees a safe, long-term victory in the AI century.
Well, I look at the exact same 16 layers, and honestly, I see a very fragile tower.
Fragile, really?
Absolutely. Yes, the software looks great, the money is impressive, but a tower will completely collapse if it has weak physical foundations. And my view is that we are relying on wild, basically science fiction gambles to solve really basic problems.
Basic problems like what?
Like energy and dirt. We need massive amounts of electricity to run these computers. We need very specific, hard-to-find rare earth metals to build the chips. And right now, those raw materials are controlled by the basic physical limits of the Earth and, frankly, by other countries.
Okay, I hear you. But let me show you why I see strength where you see fragility. The whole core of this American strategy is something called dominance through depth.
Dominance through depth, meaning what exactly for a younger listener?
It simply means having a ton of backup plans. If one plan fails, there are 15 others waiting in line. Let's start by looking at the very brain of AI, the computer chips.
Right, the silicon.
Yes, the silicon. Right now, a company called NVIDIA is just absolutely dominating this space. I mean, they made over $81.6 billion in just the first quarter of their fiscal year.
Which is just a staggering amount of money.
It is unbelievable. Their data center business alone grew by 92%. But here is the genius of the strategy. America is not just relying on NVIDIA.
Well, I mean, the entire industry is kind of held hostage by them right now, aren't they? If you want to train a massive AI model today, you basically have to go beg NVIDIA for their chips.
That is true for today. But that is exactly why the backup layers are already kicking into gear.
Okay, who's the backup?
Well, a company named AMD is stepping up right now with their new MI455X chips. And Intel, an older giant, they are coming back to life. They are building brand new factories right here in America using this new 14A chip-making process.
Right, the 14A process?
Yeah, and it's not just about chips for thinking. We are also building entirely new memory for storing data. Like companies like SanDisk are creating a brand new technology called HBF memory.
Think of memory like a backpack for the brain, right?
That is a perfect analogy. Yes, a backpack. This new HBF memory gives AI up to 16 times more backpack space. So what we have is this massive, decentralized web of private companies solving problems. If NVIDIA is too expensive, AMD fills the gap.
You are describing a really beautiful plan for the software and the design, I'll give you that. But let's talk about the physical reality for a second.
Sure.
You can have 5 different amazing brands of cars, right? Ford, Chevy, Toyota, whatever. But having all those car brands does not help you at all if there is only one road to drive on.
Are you referring to the actual manufacturing step?
Yes, the actual printing of the chips, the global supply chain. You mentioned these great American companies designing chips, and I'll add more. Google has their TPU chip. Amazon has their Trainium chip.
Meta has the MTIA chip, too.
Right, exactly. But those chips still rely on the exact same, very limited global supply chains to actually be built. I mean, designing a chip on a fancy computer is very different from physically baking it in a real-world factory.
It is true that manufacturing is extremely hard, but those custom chips you just mentioned from Google and Amazon, they are crucial to the backup plan
How so? They still have to be built.
because they are designed specifically for what those companies need. A general chip from NVIDIA is like a Swiss Army knife. It does everything, but it's kind of clunky.
Okay.
A custom chip from Google is like a perfect, sharp scalpel. Because it is highly specialized, it costs them 30 to 50% less money to run their AI programs.
Sure, I don't deny the cost savings of a good design, but you are ignoring the physical bottleneck, who actually prints the scalpel.
Well,
The demand for these AI chips is growing much, much faster than the factories can keep up. I mean, even Elon Musk recently admitted a really hard truth about this.
You mean his quote about the chip shortage?
Yes, he said that the entire global chip production, right now, the whole world, only satisfies about 3% of what his companies will actually need in the future.
Right. 3%.
3%, that is not a gap. That is a massive canyon.
It is a wide canyon, yes. But the free market sees that canyon, and it is pouring billions of dollars into fixing it. Look at what Musk himself is doing about that 3% problem.
You talking about Texas?
Yes, he is spending $55 billion to build a massive project called Terafab in Texas, and he is partnering directly with Intel to do it. America is physically building its own massive factories to make sure we do not run out of these silicon brains.
But look, you cannot just throw $55 billion at a dirt field in Texas and expect advanced computer chips to magically pop out the next day.
It takes time, yes.
It takes years. It requires highly specialized machines from companies all over the world. The bottleneck is the physical manufacturing limit of the entire planet.
Markets adjust. Supply eventually meets demand. But, let's just follow your logic for a second. Let's say Elon Musk finishes that factory. Let's say all these companies successfully print 100 million new chips.
Okay.
That naturally leads us to the very next layer of the stack, which is churning them on.
Which brings us to the energy problem. And honestly, this is where the physical foundation truly starts to crack.
Look, AI is incredibly hungry for power. I am not debating that at all. By the year 2030, American AI data centers will need 945 terawatt hours of electricity every single year.
945 terawatt hours?
Right. And to put that in simple terms for our 8th grade listeners, that is as much electricity as the entire modern country of Japan uses for everything.
Wait, let me make sure I have that right. One country's worth of computers will need the power of an entire second country?
Exactly. As much power as all of Japan.
See, that is exactly my point. We need to generate an entire major country's worth of electricity just to power new computers. Where is that coming from? Our current power grid in America is already stretched to the breaking point just running air conditioners on a hot summer day.
It is coming from rapid, unexpected innovation. First, look at the Bitcoin miners.
Bitcoin?
Yes, for years, Bitcoin companies built these massive power stations to mine digital money. Now, they are pivoting. They are renting out those massive power stations to AI companies instead.
I mean, come on, that is a tiny drop in the bucket. A few repurposed crypto mines will not power the future of a Japanese-sized energy drain.
But it is more than just the raw power. It is the infrastructure. An AI data center requires massive power density. You can't just put these supercomputers in a regular office building.
Right, the cables would literally melt.
Exactly, they would melt. But Bitcoin miners already built the heavy-duty power lines. They already built the extreme cooling systems. They have the land. And second, giant companies are stepping up in a big way. Oracle is building a $500 billion project with a B called Stargate to build giant AI data centers across the country.
Money does not create electricity out of thin air, though. How do they actually spin the turbines to make the juice?
They're looking at SMRs, small modular nuclear reactors.
Oh boy, nuclear.
Yes, but these are tiny, highly safe nuclear power plants that can actually be built in a factory and shipped on a regular truck. Microsoft is so desperate for power, They're even paying to restart an old nuclear plant at 3 Mile Island. And until those new nuclear plants are ready, companies are using hydrogen fuel cells. These cells generate clean power, and you can set them up in just 12 to 18 months.
Okay, but are we really trusting our entire economic future to these science fiction timelines? Let's look at the reality of those SMRs.
They are very promising.
They are great in a laboratory, sure, but they will not be connected to the actual grid until 2030 at the absolute earliest. You cannot power a massive AI boom in 2026 with a power plant that will not even turn on for another 4 years.
That is precisely why the 16-layer strategy works. The hydrogen fuel cells and the Bitcoin data centers act as a bridge. They hold us over to get us to 2030.
It's just not enough. Do you know how long it takes to build a regular high-voltage power line in America right now, just normal wires?
I know it's slow.
It takes 7 to 10 years just to get the government permits. 7 to 10 years just to get the legal paperwork approved to string a wire from point A to point B. Innovation moves fast, but the government permit office does not. You cannot write software code to get around local zoning laws.
I understand the frustration with permits, but history shows that when the economic pressure gets high enough, regulations change. And, when the limits on Earth get too strict, we look elsewhere. That is why companies like SpaceX are planning for orbital computing.
Okay, wait, orbital computing? You mean launching 1 million solar panels into outer space?
Yes, Elon Musk's company literally wants to put the AI supercomputers in space.
That is crazy.
But think about the physics. In space, the sun shines 24 hours a day. There are no clouds to block the solar panels. And space is a freezing cold vacuum, which completely solves that massive melting heat problem we just talked about. It is a brilliant leap forward.
See, to me, that shows absolute desperation. That is not a solid industrial plan. We are talking about launching 1 million satellites on rockets simply because we cannot figure out how to plug things into the wall down here on Earth.
It is pushing the boundaries of what's possible.
If your strategy requires literally leaving the planet to find enough electricity, your earthly foundation is completely broken.
Well, I see it as visionary, but let's bring it back down to Earth. Even if we solve the power problem, whether that's through nuclear energy or space solar panels, we still have to physically build the most advanced machines in human history.
Yes, the physical hardware. This is where the reality of dirt and rocks really hits hard.
But look at the incredible physical progress we are making right now. AI is no longer just a clever chatbot sitting inside a computer screen. It is becoming physical.
Right.
Take quantum computing, for example. To explain this simply for our younger listeners, a regular computer solves a maze by trying one single path at a time. It hits a dead end, it turns around, it tries another.
Very slow.
Right. But a quantum computer floods the entire maze with water all at once, finding the exit instantly.
That's a great analogy.
Thank you. And Google just announced their new Willow quantum chip with 105 qubits. This is a massive leap that will help AI do things like design entirely new medicines and new materials.
Quantum computing is a wonderful scientific achievement. I won't argue that, but let's look at the robots.
The humanoid robots are exactly my next point. AI is literally walking around in the real world now. We have the Tesla Optimus robot. We have the Figure 02 robot.
The Figure 02 is impressive.
It is. These are human-like machines, and they are not just toys walking around in a lab anymore. The Figure 02 robots are already working real physical jobs inside BMW car factories today. They are picking up heavy parts. They are helping build cars right alongside human workers.
I will happily acknowledge that the robots are cool. They are highly impressive pieces of engineering, but I always focus on the dirt they are built from.
You are talking about the critical minerals.
Yes, the raw materials, the rare earth elements. You can write the best, most elegant software in the world for a robot. You can make it super smart, but it still needs physical electric motors in its joints to move its arms and its legs.
Of course.
And those motors require heavy rare earth magnets. You need specific rare elements like neodymium and dysprosium. Without those exact magnets, those beautiful humanoid robots simply cannot move. They're just statues.
Okay.
And right now, China controls 70% of America's rare earth imports.
The government is completely aware of this bottleneck, though. The Pentagon has created a very strict rule to basically ban Chinese rare earth metals from American defense applications by January 2027.
Wait, 2027? That is an impossibly short timeline. You cannot magically replace a 70% supply chain dependency in just a couple of years. It's just not physically possible.
But America's not just standing still waiting for a miracle. The free market and the government are working together right now. The U.S. government just gave $400 million to a company called MP Materials.
I'm familiar with them, yeah.
They run a massive rare earth mine in California. America is digging its own mines right now to secure these metals. We are taking control of the physical dirt.
I know about the MP Materials deal, but, digging the dirt out of the ground is only step one. The real bottleneck, the really hard part, is refining it.
Refining is difficult, yes.
It's not just difficult, it's a nightmare. Refining rare earths is not like washing coal. It is an incredibly complex, highly toxic chemical process. You have to separate elements that are basically chemical twins. They are almost identical.
Right, which takes huge facilities.
Exactly. And China controls 85% of the global refining capacity for these metals. 85%! They spend 30 solid years building those massive, specialized chemical factories. You cannot just throw $400 million at the ground in California and expect a fully functioning, safe refining supply chain to just appear in 2 years.
Look, if we run out of one specific material, American companies will adapt. That is what this whole 16-layer strategy is all about. If we cannot get neodymium from magnets, a startup in Silicon Valley will simply invent a new type of electric motor that does not need magnets.
You think so?
I know so. Or they will invent a new battery that does not need cobalt. The free market treats every single physical limit as just another engineering challenge to overcome.
The chemistry has strict rules. You cannot invent a new fundamental element on the periodic table. You are forced to work with what the Earth actually provides. I really feel like we are building a giant, expensive, 16-layer digital roof, but we are completely ignoring the fact that we do not have enough concrete for the foundation.
Well, we have covered a massive landscape today. I mean, from the coding of digital brains to the limits of the power grid, all the way down to the toxic chemical refining of rare earth third.
It is a lot to process. The scale of this AI build-out is unlike anything in human history.
It really is, which makes this a perfect time to step back. If we were to explain the core lessons of our debate today to a bright young student, say an 8th grader, how would we break down this entire 16-layer map? Let's build a simple summary together.
I think that is a great way to wrap up. If I were explaining this to an 8th grader, the very first thing I would point out is that America is fighting a massive 16-part war to control the future of artificial intelligence.
Right. Point number 1.
Yeah, it is not just about making a smarter computer program anymore. It includes making much faster computer chips with companies like NVIDIA, AMD, and Intel. It involves creating entirely new types of computer memory, and it even includes building human-like robots to work in real physical factories.
That's a great start. Building on that, I think the second major takeaway, point number 2, is about America's unique superpower in this race.
Which is?
That superpower is having dozens of backup plans. Because so many different private companies are spending their own money, we are not relying on just one single idea. If one chip company fails, another is ready to take its place. If one software idea hits a brick wall, another company finds a way around it. It is a messy, highly competitive web, but that is exactly how the best ideas survive.
And I think the third and final piece of the summary brings us back down to reality. America's biggest weakness in this global race is not software. It is entirely physical.
The dirt and the power.
Exactly. These amazing new AI machines require massive, massive amounts of electricity, and our current power lines simply cannot carry enough of it yet. And on top of that, building these machines requires very special metals called rare earths. Right now, most of those essential metals still come from China,
and changing that is going to take years of hard physical labor.
That paints a very clear picture of the challenge ahead. The strategy is incredibly deep, but the physical hurdles are very real. We want to thank you, the listener, for joining us to explore these different perspectives. The visualization of this complex tech stack is truly fascinating, and there is always so much more to uncover.
We highly encourage you to keep studying the material. The true winner of this global AI race will not be decided today or even next year. It will be decided over the next 20 years as these companies actually try to build what they have designed.
As we watch this incredible future unfold, we have to ask ourselves one final question. In the race to build machines that can think for themselves, will human creativity finally conquer the physical limits of our planet, or will the Earth always have the final say?